For the first project of grade 12 computer hardware, we were instructed to solder up the GB machine, a PCB that supplies a breadboard with two different voltage levels. A secondary goal of this project was to come up with a creative circuit that exploits the board's abilities. I chose to make a NAND SR latch for my circuit. The first part of this project that I would like to discuss is the GB machine itself. The GB machine can supply the breadboard with either the direct input voltage coming from the power supply or a regulated 5 volts. It does this using the LM7805, a 5 volt linear voltage regulator. Another useful component on the GB machine is the power diode. This diode prevents shorts in the breadboard circuit from damaging the power supply and the GB machine. The one downside to the use of the diode is that it drops approximately half a volt of the input voltage. The second part of the circuit that I would like to discuss is the SR latch.
So this is how the NAND SR latch works. The NAND SR latch is an active high, meaning 1 is on both the set and reset pins in a stable state. Now, let's say that set pin goes low. We assume that this pin, for now, is a 1. So, with 0 and 1, the NAND gate will be on and set here. This means that this pin here is also a 1, which means this output is 0. Therefore, if this output is 0, this can go 0 again, and it doesn't actually matter, this is still 1. And then once you release the set, this goes back to 1, it's still 1. Then, once you want to set the inverted Q here, you pull reset low. That's going to make now this high, which is going to make this high here, making this a 0, setting this a 0, doesn't actually matter, it'll still keep it at 1 here, and then even when you get this back to 1, this will stay set, and this will be low. And that's how the SR latch NAND gate works.